So in this video I want to talk about hemostasis, which refers to the stopping of blood from leaving or leaking, because hemo refers to blood and stasis is to stop. So if we hit a nail in our big toe, we're going to bleed, but we're not going to bleed to death because we have a system in place that prevents the blood from leaving or leaking. And this system is called hemostasis, and it can be divided in primary hemostasis and secondary hemostasis. First, once we hit the nail in our big toe, the blood vessels are going to vasoconstrict, and that obviously already helps to slow down the blood flow. And it will also help that our first responders, which I've drawn here, which are the platelets, can slow down and settle onto the site of injury. Platelets can bind to what is called Van Willebrand factor with their feet. And Van Willebrand factor is found in blood, but it's kind of coiled up. But once there's an injury, it will first form a thread-like structure. It will uncoil and then bind to these blue molecules, which are collagen. And then the platelet can settle down with its feet, and the receptor is glycoprotein 1b. Once they settle onto Van Willebrand factor, they start becoming activated. And within this activation process, they will release some molecules. Release molecules that are in its granules. For example, a very important one is ADP. And then also release other molecules like thromboxane. And this activation of the platelet will change the platelet surface and also the receptors that are expressing. And one very important receptor that will get upregulating upon activation is the so-called glycoprotein 2b3a receptor. So I always like to think about this receptor as being the arms of the platelets. And I also remember always that you have two arms, so therefore glycoprotein 2 receptor, and you can stand on one foot. So this is a glycoprotein 1b receptor of the platelets. And what do you do with arms? Well, you're going to hold on to other platelets, and that's exactly what happens. So the platelets are going to reach out their arms and will just hold on to other platelets, which are also expressing arms now. And they don't want to hold on just to their hands because they can be sweaty and it might be not as efficient to get a good grip. So there's actually a molecule in between these hands of the platelets so they can get a good hold onto each other. And this molecule is called fibrinogen, where they hold on to each other. So that's happening in primary hemostasis. So in the end, you have just a little platelet plug here, which happens very fast, but it's fragile. I mean, it can move easily. It's not going to be very stable. And so what we want to do eventually, we want to just glue up this platelet plug. And that's actually what happens during secondary hemostasis. During secondary hemostasis, that's when the coagulation cascade kicks in, when a lot of molecules, proteins are activated. That in the end will form fibrin molecules. And these fibrin molecules polymerize. Then you're going to form these stable strands, and they're just going to glue up this platelet plug and form a clot. And also red blood cells will swing by and get caught kind of by this fibrin polymers, and that makes it even more stable. So this is relatively slow and very stable. But eventually this can also become dangerous because you don't want to have the clot formation going on forever. So because you also don't want to stop the blood flow. You don't want to prevent any blood flow through the blood vessels. So we have to have a system in place that we can also degrade this clot. And this is called fibrinolysis. And as the name already implies, it just lyses this fibrin polymer so that you can lyse the blood. And I just want to finish up with saying that there are many regulatory factors built into these processes to try to keep a balance between preventing the blood loss without blocking the blood flow. This concludes the video on an introduction to hemostasis.